Here showing the second law of thermodynamics. Before going to start second law of thermodynamics, I'll have to know that what is first law of thermodynamics. So first law of thermodynamics is energy law of conservation, means energy neither being created nor destroyed. It may transform. So first law of thermodynamics is a conservation of energy. So the change in a system internal energy is equal to the difference between heat added to the system and its surrounding and work done by the system and its surrounding. So now move to the next slide. So topic to be covered in this presentation is second law of thermodynamics and spontaneous process and non-spontaneous process and enthalpy. So now move to the next slide. So thermodynamics law first is a spontaneous process. What is spontaneous process? So a process in which a proceed of its own accord without any outside assistance is termed as a spontaneous or natural process. So the reverse process which does not proceed to its own is referred as a non-spontaneous or unnatural process. So in general, the tendency of a process to occur naturally is called as spontaneity. So the example of spontaneous process are climb jumping is a spontaneous process, heat flow, uh, uh, when a two ball of metal, one hot and one cold, are connected, heat flows spontaneously from the hot ball to the cold one, never from cold to hot. This type of process is a spontaneous process. And another example is a gas flow. When a vessel containing a gas is connected to another evacuated vessel, the gas spread throughout the spontaneously unless the pressure is same in both the vessel. So this is the example of spontaneous process, means free flowing process, that is natural process is called as spontaneous process. And uh, example of non-spontaneous process. So the spontaneous process is a directional process, and non-spontaneous means a mountain climbing is a non-spontaneous process because mountain climbing required work. So heat flow when two balls of metal, one hot and one cold, are connected, or the heat flow from cold to hot is required work to transfer heat from one place to another, says by mean of refrigerator pump. So gas compression is another example of that. So the process of compressing the gas into original vessel cannot occur unless work is done on it. So here showing the gaseous molecule and it's showing the empty. So this process is a uh, spontaneous process. Suppose we remove this wall, the fill gas is this container of suppose stopped by this wall. Suppose we release this wall, the gas is automatically fill this another bulb. So the overall gas in both bulbs are equal. So this process is a spontaneous process. Suppose we are trying to collect gas in a one chamber, is not possible. It's a non-spontaneous process. So it's an example of non-spontaneous process. Criteria of spontaneity. So some important criteria of spontaneous physical chemical changes are listed below. So a spontaneous change in one way or unidirectional, for reverse change to occur, work has to be done. So for a spontaneous change to occur, time is no factor. A spontaneous reaction may take place rapidly or very slow. So spontaneous process is uh, where the time is no factor, means no time is fixed for the completion of the process. So if a system is not in equilibrium state, means unstable, a spontaneous change is invariable. The change will continue till the system attain the state of equilibrium. Once a system is in equilibrium state, it does not undergo any further spontaneous changes in state if left undisturbed. So a spontaneous changes is accomplished by decrease in internal uh, enthalpy, means delta H. So this is the criteria of spontaneity, means so here the entropy. So the entropy is implied that only such reaction will occur which are exothermic, but the melting of ice and evaporation of rain water are exothermic process which proceed spontaneously. So clearly there is some other factor in addition to delta H which govern spontaneity. It is the second law of thermodynamics which introduced this new factor that is called entropy. So for many years scientists believed that only exothermic changes resulting in a lowering of internal energy or enthalpy could occur spontaneously, but melting of ice is an exothermic process and yet occur spontaneously. On a warm day, another example is on a warm day, ice melt by itself. So the vaporization of water is another example of spontaneous endothermic process. So thus across the need of inventing another driving force that affect the spontaneity, and this was known as the entropy change, means delta S. So the entropy of a system is clearly shows that some factor in the addition of delta H where which govern spontaneity, means the reaction will occur which are exothermic, but the melting point of ice and vaporization of rainwater are also considered as endothermic process which are spontaneous process. Now move to the next slide. Spontaneity and randomness. So melting of ice and evaporation of water. So there is an increase in randomness, means disorder of the system. So the water molecule in ice are arranged in a highly organized crystal pattern which permit little movement. So the spontaneity and randomness is a disorderness of the system. As the ice melt, the water molecule become disorganized and can move more freely, and the movement of molecule become freer still when the water evaporate into space, as now they can roam about throughout the entire atmosphere. So in other words, we can say that the randomness of the water molecule increases as ice melt into water or water vaporize into space. So the any systems where, for example, water is, suppose ice is converted to water, there is a randomness will increase, then water is also got vaporized by the heat. So the another randomness is increased, means disorderness is increased at that system. The spontaneity or randomness will increase of the system. So we can say the water molecule or ice are arranged in highly organized crystal pattern and as compared to the water and vapor molecule. So vapor gases. So this increase the randomness of the system. So increase in randomness favor a spontaneous changes. So randomness will increase the randomness will change in promote the spontaneity of the system. So a change that bring about randomness is more likely to occur than one that bring about order. So let us suppose we have a suit of playing cards arranged numerically. We can see that the sequence of card is certainly high organized. Now if we throw the card into the air and collect them and re-stack them, we will almost surely find that they have been placed at random sequence. So this is a disorderness will increase when we throw the cards in air and collect further, so the randomness will increase. So this is expected because when the cards are tossed, there are many ways of them to be disordered, while there is only one way of them to come together again in their original sequence. So thus on the basis of the pure chance or disorderness, sequence is far more probable than the ordered one and with which we started. So the same law of chances apply to any physical or chemical process. So the increase of randomness means suppose in any system we provide energy, the molecule get energy and there the randomness will automatically increase. Suppose we have two types of solution, two types of water solution, water glass. Suppose we taking two glasses of water when temperature of that glass is 25 degrees, another temperature of the glass is 75 degrees centigrade. So the randomness of the 75-degree water glass is high as compared to the 25 degrees centigrade water glass. So the increase of randomness is a favor the spontaneously change. Now move to the next slide. A definition of entropy. So the entropy is a thermodynamic state quantity that is measure of the randomness or disorder of the molecule of the system. So the symbol of entropy is S, while the change in disorder accompanies a process from start to completing is represented as delta S. So the entropy of a system is a state function and depend only the initial and final state of the system. So state function is depend the initial value and final value. So the change of entropy means delta S for any process is given by the equation delta S equal to S final minus S initial. So S final is greater than S initial, so delta is positive. So this is the definition of entropy, means this is a thermodynamic state quantity that are measured for the randomness or disorder of the molecule of the system. So entropy, a process accompanied by an increase in entropy, tend to be spontaneous. Let us consider a molecular system in a state A and state B. In state A, all the molecules are arranged and highly ordered. Here they are showing the highly ordered molecule, while in B state, the molecules are present as random and is highly disordered. Suppose you are showing the S red portion and green portion. These all are showing a disordered pattern. So by definition, the entropy of A is low and that of B high. Thus, an increase of entropy occurs in the change from A to B. So, according to the law of change means probability, A is less probable and B is more probable. Therefore, the change from A to B is a spontaneous process. So from equation 1 and 2, it's follow that the change from A to B, which is accomplished by increase of entropy, will tend to be spontaneous. Hence, we can say in that there is a change in the system which accomplished by increase in entropy and tend to be spontaneous, means randomness will increase the spontaneous process. Now come to the next slide. Statement of second law. So the second law of thermodynamics states that whenever a spontaneous process takes place, it is accomplished by an increase in the total energy of the universe. So more specifically, we can take the term universe to mean the system and the surrounding. Thus, delta S universe is equal to delta S system plus delta S surrounding. So the second law is state above tell us that when an irreversible spontaneous process occurs, the entropy of the system and the surrounding increases. In other words, delta S universe is equal to less than 0. Sorry, delta S is less than 0. When a reversible process occurs, the entropy of the system remains constant. So delta S universe is equal to 0. So since the entire universe is undergoing spontaneous change, and the second law can be mostly generally and constantly says that the entropy of the system constantly increases. So they are showing here the solid, liquid and gases. So the entropy means disorderness of the molecule will always increases when we going to solid, liquid and gaseous state. So the entropy of a system varies directly with temperature. The lower the temperature, the lower the entropy. For example, water above 100 degrees centigrade at 1 atmosphere exists as a gas and has higher entropy, means higher disorderness. The water molecule are free at room about in the entire container is cooled. The water vapor condenses to form a liquid. Now the water molecule are confined below the liquid level but still can move about somewhere freely. Thus the entropy of the system has decreases. So on further cooling, the water molecule join together to form ice crystal. So the water molecule in the crystal are highly ordered and entropy of the system is very low. So they are showing you this three types of orderness: very low disorder, randomness and high order randomness. So the entropy of the system is that. Now move to the next slide. Here's showing the solid example showing here. Calculate the standard entropy for formation delta S F is equal to CO2 gas given the standard entropies of CO2 gas, carbon and oxygen gas, where are 2.13, 5.74 and 2.05 joule per Kelvin respectively. So we, after putting this value in this equation, we got that 2.86 joule per Kelvin. So this is a sole example of entropy change. Now move to the next slide. Here the summary of this presentation. The second law of thermodynamics is that the randomness of the system, and the statement of the second law is showing the entropy, means disorderness of the system. Suppose we have three solutions solid, we have three state of solution. First one is solid, second one is a liquid, and third one is a gas state. So disorderness of in gases is high as compared to the solid portion, solid system. So now move to the next slide. Here they're showing the references and textbook source of references. The material presented in this lecture has been taken from various book and internet sources website. So this is instructional material for the instructional purpose only, and these references were used for the presentation of for this presentation. So thank you for watching this presentation.